In this video, we consider first light as an electromagnetic wave, polarized and unpolarized. Then we consider how polarizer works. Next, we consider the system of two polarizers, and finally, we solve the problem involving two polarizers. Let's go. It is well known that electromagnetic wave consists of two components, electrical components and magnetic components, which are perpendicular to each other. In this video, we will consider only the case when electric component is always parallel to y-axis. It means that this component is always in the vertical plane, which is called plane of polarization. In our case, it is xy plane. Now we consider several electromagnetic waves traveling in the same direction. Each wave has its own plane of polarization, and direction of polarization is shown here by arrow. In this case, the resulting light is called unpolarized light. Now we consider what is the polarizer. Let's consider unpolarized light which travels in some direction, and this light meets the device which is called polarizer. This is a planar sheet of some material, and the feature of this material is that it is transparent only for those waves which have specific direction of electric field. This direction is called axis of polarization and is characteristic of polarizer. So we have unpolarized light before polarizer, and we have polarized light after polarizer, and we know direction of polarization. If intensity of unpolarized light is I0 and intensity of polarized light is I1, then a relation between these two intensities is very simple. I1 is equal I0 over 2. And let us consider the system of two polarizers. First, we consider the single polarizer, which is illuminated with the source of unpolarized light. The axis of polarization of this polarizer is here, so the electric component of light after passing this polarizer will point in this direction. If intensity of unpolarized light is I0 and intensity of polarized light is I1, then these two intensities are related with this simple equation which we found before. And then we introduce the second polarizer, and the axis of polarization of this polarizer makes angle θ2 with vertical axis. The electric field after the second polarizer will be polarized in this direction, and to find its magnitude, we draw here direction of E1 and direction of polarization axis of the first polarizer. This angle in this case will be equal θ1, and this angle, the angle between the axis of polarization of these two polarizers, will be θ2 minus θ1. And then a magnitude of E2 can be found according to this equation. So E2 is E1 times cosine of this angle. Because intensity I2 of the light after polarizer is proportional to the square of E2, this intensity can be written in the following form. Replacing I1 with I0 over 2, we will get the final answer for intensity I2. Let's consider the problem which involves two polarizers. Given is intensity of unpolarized light, angle θ1 and angle θ2. We need to find intensity of light after second polarizer. Just in case, here is a printed version of the problem. To find I2, we will use equation which was derived previously. Using given values of parameters, we will have the following equation, and after calculation we have the answer. We need to leave here only two significant figures, so the final answer is the following. I2 equal 21 watt per square meter. If you like this video, you may want to click like button, leave a comment and subscribe to my channel. Thank you.